Now guys, now we have to prove this, integral is equals to square root of pi. This integral can be regarded to as the Gaussian integral. So how can we prove that the value of this integral is equals to this? So the first step is to convert it into the integral of the polar coordinate. And how can we do that? This integral has a property that when you square it, it's going to give you the integrals of two distinct variables. So let's look at it. Now, if I say let the square root of pi equals pi, so meaning I'm going to have the integral of minus infinity to infinity of e raised to pi minus x squared dx will be equals to what? I. So as I have said earlier, we can square both sides so we can have our polar coordinates. So how do we do that? So squaring both sides, we have this transform into integral of minus infinity to infinity of e raised to power minus x squared dx multiplied by the integral of minus infinity to infinity of e raised to power minus y squared dy, all equals I squared. So however, we can still join these two integrals together. So let's join this together. So by the time we join this together, we're going to have integral of minus infinity to infinity of e raised to power minus x squared plus y squared dx dy, all equals I squared. Can we see this? So now we're going to extend this and probably create a value for this, because from the polar coordinates we know that x squared plus y squared all equals r squared. Note, and we also know that r d theta is equals to what? Dx dy. So the integral will be transformed into, anyway, it's going to be a double integral here because we have two variables. So it's going to be a double integral. So we have the double integral of minus infinity to infinity of e raised to power minus r squared, and we're going to have r d theta. So what next? Let us evaluate using the shell integration. We're going to use shell integration in this aspect. So how do we apply the shell integration? The shell integration says that this integral will be transformed into 2 pi to 0 and 0 to infinity. So we have e raised to power minus r squared, then we have r d theta. Anyway, this is going to go with the d theta, so this integral goes with this. So by the time we evaluate this first integral, we're going to have 2 pi, then we have integral of 0 to infinity of e raised to power minus r squared dr. So the d theta has been evaluated with this first integral, and that gives us theta. By the time we are evaluating that, let me quickly explain that the integral goes with the d. So we have 2 pi, 0 to 2 pi of limit of theta. By substituting that, we have theta. We have 2 pi, So now we have this. How do we evaluate this? Don't forget, everything still equals I squared. So let's take it from here. So now that we have this, we can just say let u equals r squared. So that the u, the r will be 2r, and at the same time, the r will be what? The u all over 2r. So substituting that into the integral, we have integral of 0 to infinity of e raised to power minus u. And don't forget, I omitted the r. So now we have r. The r becomes the u, then the 2 pi here, the u all over 2r. So as this will go with this, and also this goes with this. So then the integral becomes 0 to infinity of e raised to power. Don't forget, we have a pi left here, minus u du. So by evaluating what is here, it's very simple. We're going to have pi into bracket e raised to power minus u, then infinity, then 0. Don't forget, all equals I squared, as we have been showing. So now we have pi into bracket e raised to power minus infinity minus e raised to power minus 0. all equals I squared. So from here, the pi into brackets 0 minus 1 all equals I squared. So everything in this bracket gives us 1. 1 times pi gives us pi equals I squared. So then I will what? Root of pi. So we have actually proved that this integral is equals to square root of pi. Thanks for watching. Please subscribe to our YouTube channel. It is free. Thank you.